points. Now, in the examples that we've seen so far, the domain of all the variables is a set of real numbers. We put the domain, remember, as a review, is your set of x's. So domain for all of these has been the set of all real numbers. In these cases, the graph of an inequality consists of all points in a region indicated by shading. However, in some situations, especially dealing with story problems, the domain of each variable is going to be discrete. Remember, discrete means that you're not going to use decimals. It's just the integers. In these cases, the solution set, instead of having an entire region, it consists of those points whose coordinates are both integers. So in which case, both coordinates are going to be discrete. So we're not going to include decimals. When we shade in a region, we're including decimals. So these points are called lattice points. If there are not too many lattice point solutions, you should indicate each with a dot on the plane rather than shading an entire region. Oops. So let's look at a story problem here. Alita wants to buy P pencils at 12 cents each and R erasers at 15 cents each and spend no more than, we're going to change this to $1.20. What combinations P and R are possible? Okay, so first off, we need to write an inequality here. So it's 12 cents for each pencil, and it's 15 cents for each eraser, and she wants to spend no more than $1.20. So that means she can spend exactly $1.20, but no more than that. So it's got to be less than or equal to. So now to graph this, to figure out my x and y intercepts, let's use P as your x-axis and let's use R as your y-axis. To define my p-intercept, that's where we cover up the r. So I'm going to take 1.2, or $1.20, divided by 0.12, and when you do that, you get exactly 10. So my p-intercept is at 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 is right here. Now my r-intercept is going to be where p is 0. So if I divide 1.2 divided by 0.15, I get 8 as my answer. So my r-intercept is 8. 1, 2, 3, 4, 5, 6, 7, 8. Now, is this a situation, before I connect these, is this a situation that's continuous or discrete? Well, it's going to be discrete because we're not going to purchase a decimal amount of pencils or erasers. So here's what we need to do in this situation. Even though it says it's less than or equal to, I'm not going to use a straight line here. Because remember, a straight line is not used to indicate discrete. And what we need to do here is we need to use individual points if it's discrete. So I need to come up with, well, what's the points that would be on this line that are between R and P? The best way to do that is to figure out what my slope is. Remember to find the slope if it's in standard form. It's the opposite of A divided by B. So to find the slope here, it's going to be negative 0.12 divided by 0.15. Now if you do this on your calculators, you get a slope of negative 0.8. Now a better way to look at that is that's going to be the same as negative 8 over 10, which if you reduce that, 2 goes into both of those, so this is going to be negative 4/5. So that means that from this point here, I'm going to go down 4 units and to the right 5 units. 1, 2, 3, 4, 5. Down 4 units and the right 5 brings us here. And so I would, like, now if we do a dotted line here, my solution set, we're not going to have negative numbers here, so my solution set is going to end there. But it's going to be, instead of shading above or below this line, because if I put 0 in for P and 0 in for R, this would be a true statement, so 0 is so the point 0, 0 is a solution. So that means all the solutions under this dashed line are going to be included. So in that case, it's going to be all the points that intersect the grid lines. Below that line. Now we know that there's no other points on that line because we used our slope. So these are going to be my solutions. So we're not going to shade in this area. So any of those points would work. Like if I have the point, if I bought 3 pencils and 3 pencils and 4 erasers, that'd be this point right here. That'd be a solution. I would have enough money to be able to do that. I could buy 1, 2, 3, 4, 5, 6, 7 pencils and 1 eraser. I would have enough money for that. But if I bought 7 pencils and 3 erasers, I would not have enough money for that because it's outside of that feasible region. Okay, why don't you guys work on this one on your own? So why don't you pause the video and hit play when you're ready to check your answers. Okay. So for this one it says, a ferry boat carries cars and buses across Lake Michigan. The boat has space for 12 cars. A bus takes up the space of 3 cars. Draw a graph showing all possible combinations of cars and buses that can be taken in one crossing. So let's do this. Let's say X represents the number of cars. And let's say if we use Y to represent the number of buses, then our equation would be that we would have X plus 3Y, and the boat has space for exactly 12 cars, or 12 vehicles, I should say. So it's going to be less than or equal to 12. So my x-intercept here would be right at 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 would be there. My y-intercept would be at 4. 1, 2, 3, 4. Remember to find the slope here. The easiest way to do that is it's the opposite of a over b, where a in this case is 1, so it's going to be negative 1/3. So that means from this point I go down 1 and over 3, down 1 over 3, down 1 over 3, down 1 over 3. So those are all the points that would be included that would be on the line. Remember, all the other ones are going to be decimals, so we're going to use, this is going to be discrete. So even though it's less than or equal to 12, the points that are on the line are included, but we don't have any points in between there because it's discrete, they're decimals. This dashed line just kind of helps, gives me a boundary now when I find my other points. By the way, I know this would be 0, this would be below the line, because if I put 0, 0 in there, I would have 0 is less than or equal to 12, which is a true statement. So those would be all your points. That would be your lattice points. Okay, so this idea of lattice points is a very small feature though, so if you don't quite understand how to do that, it's not a huge deal. It will be covered a little bit in your assignment, but the majority of your assignment and what you'll need to know for the test and the quiz is what we did at the beginning here. So don't forget, when we graph an inequality, always shade either above or below the line, and always either use a dashed or a solid line. So remember, we use a solid line if it's less than or equal to or greater than or equal to because the points are included on the line. We use a dashed line if it's just less than or if it's just greater than because the points there are not included on the line. So, with that, good luck on your assignment.